You are not going to regret sticking around because we now have the privilege of listening to James Reuter, NASA Associate Administrator, basically in charge of all things innovation at NASA. As I said, he's the Associate Administrator for Space Technology Mission Directorate in DC, and he provides executive leadership and management of the technology programs for STMD with an annual investment value of more than $1 million. Please help me welcoming James Reuter back to the stage.
Good afternoon. And I want to say it's a pleasure to be here, and it's been just fantastic reception. I can't say enough about what's going on here. And Justine, I think especially last night, you really outdid yourself. We see times where there's unveilings and the screen comes up and that sort of stuff, and you wait until the right time to do it. Well, last night we went up to Grandview, and it was almost a whiteout, because the snow that was going by, and so we're up there and you can't see the three rivers. But then she starts her program. It clears off. The sky clears off. The whiteout goes away, and it's a bright view. And I don't know how you controlled the weather, but you did it perfectly. So earlier today, and really almost all the day, we've talked about the future of NASA and opportunities for more of the tri-state region to help us achieve our exploration and science goals. So when I was preparing for this conference, I thought a lot about local success stories and current partnerships we have charting our path to the moon, to Mars, and beyond. And there's a few stories I'd like to share today along those lines. Together, I think they demonstrate how companies and universities with innovative ideas and specialized capabilities can work with NASA, Space Tech, that's what we call ourselves, to advance new technologies. Like we like to say, technology drives exploration, and we say technology drives the global space economy. In the coming months, NASA will launch Artemis 1, the first flight of the Space Launch System rocket and the Orion spacecraft. A small business here in Pennsylvania with a long history of manufacturing advanced materials has played really an important role for that mission. Bally Ribbon Mills, Bally just south of Allentown, I think a little ways, has collaborated with NASA actually since the Space Shuttle program. It's great really to see their partnership continue, and they support our next step directly in human exploration with implementation of new technology. The company developed, tested, and delivered a woven thermal protection system. They're an world's expert in woven materials and for high strength, high thermal applications. And they tested that material for Artemis. Lockheed Martin, for the Orion capsule, used it as their heat shield compression pads, which insulate and protect the spacecraft during launch and on-orbit operations. So there's a connection between the service module and the crew module. And then when you need to separate, and so then that creates penetrations. Those penetrations are particularly vulnerable for heat flow to get in and could be catastrophic. But the material is what's protecting there and absorbing the loads. And then when there's a shock event, which is the separation bolts, then they absorb that load too. So it's an incredibly complex, small item that is the entire mission is totally reliant on, made here in Bally. Following the uncrewed test, NASA will carry the astronauts to the moon, return them safely to Earth with the help of this technology. And then there was another Space Tech funded project that we had with them where they invented a new weaving capability to potentially support future science missions to Venus and Saturn. Really tough challenges. And it looks great. It looks really promising. It's something that potentially for future missions, if we ever get to a point of, to landing in these environments, it has a great opportunity for us as we're going forward. Another company, of course, is the one we've been talking about an awful lot today, the Astrobotic technology, contributing to Artemis with strong roots in the SBR program. And I don't know if John's here, but I'll take the liberty of quoting him. He said the SBR awards that they've gotten were the lifeblood that helped get the company going. In fact, I think early on, they've had over 20 SBR awards from us, and one last night also that we just contacted. And it's their Cube Rover, and it'll give it an opportunity to fly through lunar night. So we're excited about that too. Anyways, it's really a common theme. I can name 10, 12 companies around the small businesses. Right now, it's just changing the way we think about things. All these small businesses have a great idea and a great product. They're developing it. We give them seed money. They're getting they're raising capital other ways too. It's heavily leveraged generally, and we're just changing the way we're doing business. It's really exciting. And many companies like that, I could name them for multiple times. In fact, we are putting together a website, of some of the great success stories like this. So now, after that, of course, Astrobotics, since that time, you start small, and now all of a sudden they're getting the large contracts for, 3 different moon missions, through the fantastic CLIPS program. One more commercial program. I don't think we've tried one of these commercial that hasn't worked. They've all been successful. We have Flight Opportunities, which is another one too. And they also, though, another thing they've been working on is, I think they've been very strategic about it because they really look to be logistics and utilities on the moon company. Well, the most critical technology, the thing that makes or breaks the moon, is really power. So a couple of the things that they've been looking at, one is wireless power transfer, which is really essential for the environment of the moon. And another one is, we call this vertical solar array technology, or VSAT. And the idea behind VSAT is, well, if you look at the South Pole or the North Pole, really at the poles, the sun, by the nature of what's going on, the sun is basically always at the horizon, year-round. And so if you go up 10 meters and then put your solar arrays up there, or 20 meters or something like that, now you've got an incident angle that you can generate power. And if you put a couple of them together out there and link them through power cabling, or and wireless power transfer and stuff, now you've got a network that is basically continuous power for 10 or 20 kilowatts or whatever you have. And this company's been, has that in their mind. And I think they've had it in mind all along. It's so exciting to see. It's one of the favorite things. And the other thing is, it's kind of fun for me too when we look at what we try to do. We like to try to incentivize to get there, but we also try to look at what are the technologies that if we just develop this, it would help enable. And so it's really fun to see some of those. And you see on the Peregrine lander, there's terrain relative navigation. It's the Opal version, or it's the astrobotic version, but we developed it first for Mars. And it helped to land the Perseverance rover in the Jezero crater and worked perfectly. Converged on the solution within 10 seconds as we went through it. So so that's an exciting part of what we do is to try to look for those sort of things. Then I'll say, kind of looking around also, of course, Astrobotic got their start with Carnegie Mellon, and there's still a strong partnership today. Our Small Business Tech Transfer and Tipping Point Awards that we've made have supported industry university teams' development of a miniature rover that they call the Cube Rover, which now, since last night, we've given an award for to develop further. And I think it's a common theme. I know you guys have mentioned it a few times, but I can see it too. If you look at, what's the strengths of the regions and stuff, you really have, and the tri-state. So West Virginia University has done a lot in robotics and autonomous operations. The people here and stuff, and really through that tri-state region, it's an obvious area that you have strength, I think, as a community. I mentioned it, but we make investments, joint investments with industry on important capabilities through our tipping point call and what we call an announcement of collaborative opportunities, or ACO. Our most selection, and so the idea behind these is we try to give fairly broad topics, give it the opportunity to be innovative of the types of things, and it's a partnership so everybody, both of us have to have stake in the game. It's something that has to have a strong business case and something that also that supports our needs as well, potentially. It's really been a fantastic program for us. The response this year has been just phenomenal, just as it's grown every year in the last 5 years since we've had it. We're currently in the 2022 proposal cycle, and we just got all the preliminary proposals not too long ago. What we do, it's another thing we try to do because we're not $1 billion investment, part of that, or even hundreds of millions of dollars. So we recognize that some people, that's in order to, we try not to get too overburdensome on the bid and proposal aspect of it when we recognize that the relative dollars are much smaller. So what we do in the tipping point and solicitation is we have ask for a preliminary proposal, which is kind of a white paper and ROM costs, not commitments and stuff. Then we take all these in, and then we'll go through a review, and we decide which ones do we want to ask for a full proposal for. And then my pledge is, this year might be a little tough because our budget is really uncertain, but my pledge is, what we try to do is, if you've been asked back, you've got a pretty good chance of being picked, so that it's a little more comfortable for you to say, okay, yeah, let's put something in. And by pretty good, to me, I say I got to make at least 20 to 25% chance. And we've had some that were over 50% that once we asked for them, so it's in that ballpark, and it's been really a fun program, enjoyable program for us, and it's just flat out exploded. I was at Space Symposium a couple weeks ago, whenever it was, and everybody we were talking to around there was really ramped up on that program and stuff, and talking about they were going to submit. But anyways, one of the companies that's kind of a regional thing, again, for you, the Tri-State, that was selected back in 2020, the last version we had of this was called, a company in Columbus, Ohio, called pH Matter. They received both a tipping point and an announcement of collaborative opportunities that were complementary to each other. With the tipping point, they're developing and demonstrating a reversible regenerative fuel cell capable of producing power and storing energy on the lunar surface. So there's potentially a large amount of water on the moon, so we can utilize the water to, as power generation, and in a regenerative cycle, then it can be closed loop. And through the ACO part, we've pledged and have support from NASA Johnson and Glenn to work with them to provide expertise and give them access to some of our test facilities. So that's one of the things we do with the ACO, is there's no exchange of funds, but we do provide expertise and funding as we're going through that. And so our team is kind of working with them to define lunar water contaminant compositions, cell stack specifications, and hopefully it will lead to the point of simpler systems for lunar energy storage, or at least another alternative method, and utilization of resources on the moon. There are other ways that companies can, in your region, can work with us more, or kind of coordinate with us. Sometimes it's not just the solicitations, but what we've done is we're looking for your input. And so we have what we call developed a strategic technology framework. I can almost say that. And then that's part of the idea is, let's have something out there that's a framework that we can use and you guide our investment strategy for it. And so what we've done is, with that, is we've then created 4 thrust areas that we're going to invest in. Those 4 thrust areas are space transportation, which we call GO, expanded access to surface destinations, which we call LAND, sustainable living and working farther from Earth, which we call LIVE, and transformative missions and discoveries, which we call EXPLORE. So if you want to know what our strategy is for investment, it's GO, LAND, LIVE, EXPLORE. Each thrust then has an essential component of the technology we need to develop further. We developed outcomes that we want to try to achieve in the future against those thrusts. And then we identified the capabilities that we need. And then what we've done is created what we call envision future states of what we'd like to see this technology come. With that, saying what we think the state of the art is, what gaps we think are there. And so what we've done is now we want community input. We're releasing this product. We haven't quite, but they're almost all complete. They haven't gotten through my final check and stuff, but that's about where they are. We did just release one through NRES, I think, is it? Yeah, anyway, we did just release one on the go for out there, and we're asking for comments between now and May 20th. And then the idea is we'll follow that with LIV. In fact, we have this Lunar Service Innovation Consortium, which I'm going to talk about here in a little bit, but the spring meeting there is May 4th and 5th, and we plan to introduce the lab, the LIV ones there, because that's sustainable living and operating on the moon. And so we're looking for feedback, and we want it to be a product that kind of lives. So, you almost certainly you'll find lots of things. Well, wait a minute, we think it should be this or something like that. Or if you just want to use it as a reference, that's great too, and stuff. So we'll look for that. And then I mentioned it, but the Lunar Surface Innovation Consortium is another place that I think you can you might consider participating. I know Astrobotic is active in it, but it's not everything, but there's a lot of great things that we're doing with there. What we tried to do. We actually formed this, and the official kickoff was February 28th, 2020. And so, we had the kickoff face-to-face, and then we haven't had much face-to-face, but now the spring event will be hybrid. But the idea is we want to go back to the moon. Apollo was awesome, but we didn't stay. So we think part of the way that you have to go back to the moon and be sustainable about it is you've got to have engaged community. And there has to be something in for that community. And it can't be just an all government-led thing as we're going through it. We have to have that enabling before we go through that. And so what we've been doing and Johns Hopkins APL Applied Physics Lab runs this for the consortium for us. And right now it's up to actually 600 organizations that are participant. Across all 50 states. That was a big goal for us, Puerto Rico and DC as well. Really the idea is bring together ideas and challenges for how we kind of can stimulate a lunar surface economy, and what do we really need to get in place for that. And then we have things like workshops. We have these six focus areas, and those areas are ones that they meet monthly. And talk about things. We have workshops that we have on an occasional basis. They're usually user things. And just kind of as added bonus, Harrison Schmidt, the geologist that was on the moon on Apollo 17, he shows up almost all the time and is actively engaged. So I think people have kind of gathered that if there's a workshop, there's a good chance he's going to be there. So anyways, what I'd encourage you is just to kind of look it up. It's LSIC. You can type in, I don't remember what the actual URL is, but it's JHU APL LSIC, and you'll get there. Anyways, just consider it. We also support R&D at U.S. colleges and universities in a lot of different ways. It's a big part of what we do. In fact, we have core things that we try to accomplish. One is to be transformative on developing technologies to enable new missions and discoveries. The second one is to help enable the U.S. space economy. And then the third one is to inspire. And so that goes through universities as we go through it, as well as K through 12. So for us, we have a research grants program that supports academic research from graduate students to tenured faculty members to multi-university engagements. They all help to enable new missions and discoveries. And like the example with Carnegie Mellon and Astrobotic, it's a good place for kind of cooperation and coordination between industry and a university. The research institutes are probably one of my favorite, and because we give a general topic, and then we team at least 3 universities that have 15% stake in it or more. This is a 5-year thing, and then often encourage to have more. And if there isn't a minority serving institute, you basically aren't going to get picked, in some role. So, but other examples, we do a lot of prize challenges, and that kind of marries with our universities as well. So a few years ago, the student team from West Virginia University demonstrated autonomous rover technologies in a NASA prize challenge. The Mountaineers won $750,000 in the final phase of our sample return robot challenge. They've since then, their robotic and technology center has teamed with Maxar Technologies, and so they're a significant contributor to one of our major projects in space tech on in-space assembly and manufacturing demonstration. Penn State participated in a 3D printed HAB challenge that we hosted, and they won more than $450,000. The NASA competition aligned with their research themselves towards advancing construction technology for affordable housing on Earth. In 2019, the team printed a 1/3 scale version of their habitat design. That's what they won the award for us. Then they went on to fly a related material demonstration on the International Space Station. Things tend to build as you go through this. And now they're constructing a small-scale 3D printer to send to the ISS for more experiments as they're going through it. And then the prize money helped Penn State establish an additive construction laboratory, which in late 2020, they partnered with a nonprofit to study the feasibility of 3D printing homes for Native people in Alaska, considering the heavy snow and permafrost conditions and earthquakes. So often, our space technologies help resolve key challenges we have on our home planet. This is often cross-cutting technologies that we're dealing with. All we need is creativity. Our programs also engage K through 12 STEM students. We had a first ever Tech Rise student challenge that we just completed in January. It was run by our Flight Opportunities program, which sponsors in a very similar way to COTS and the other things. It sponsors payloads that we put on suborbital vehicles. We average about 60 payload flights a year that we sponsor and stuff. So, but what we did on the Tech Rise Challenge is we invited teams of 6th to 12th grade students to design, build, and launch experiments on suborbital rockets and balloon flight. What we said was, if you had a bucket of parts, a 2U configuration, 8-inch by 4-inch by 4-inch, what would you, and you had the opportunity for a high-altitude balloon or a rocket for suborbital, what would you do with it? And then we divided the country into regions so that somebody from Arkansas wasn't competing with Pasadena, California, but they were competing in their regions. And so we awarded those. So this is their preliminary idea, and now we awarded 57 awards for this. We ended up, I wasn't sure, honestly, I wasn't sure when we started this that we'd get 57. We said we were going to do 57 awards. It was maybe kind of an odd number, but the reason for it is we could conceivably have picked one per state and every territory. And so we didn't. We picked 37 states. We also gave benefit for Title I schools, 5 points. Over 60% of the awards went to Title I eligible schools. So I thought, but Future Engineers ran this for us. They did a fantastic job of getting the community. I thought it might just be a bridge too far because we were kind of starting quickly and stuff, but man, did they engage the education community. We even got them to talk at one of the big education forums, and we got the spot just before Joe Biden. So you know, the word got out. So anyways, we're also pleased, of those 57, 4 of them went to this region, tri-state region and stuff. So we'll go through it. And we're really looking forward to doing another round of this. We haven't quite finalized it. And the whole idea is, okay, we went through the school year, but we need to apply these things quickly when they get done, because the students have to still be around and stuff. So, but we're hoping to have another run, and we really look forward to considering applications from this area too. It's a great way to get engagement. In fact, I was on the hearing, and Senator Moran from Kansas said that one of the award they received in Kansas was this high school that was 116 students total, and they got together and won one of our awards. So finally, I probably have gone on a little too long, but I just want to preview quickly 3 upcoming technology demonstrations. Later this spring, we're sending what we call the Capstone CubeSat to the moon. It's a pathfinder for the Artemis program. Capstone's led by Advanced Space, in Colorado, and they collect data and test navigation technologies in a unique orbit for Gateway. We're going to get there first in a very small spacecraft. There's an upcoming Deep Space Optical Communications demonstration. We're launching it on the Science's Psyche mission, a fantastic mission. If you don't, they have so many exciting missions. That's one of them. And we'll further demonstrate optical communications from deep space and help the community standardize the technology. And then we're doing a lofted, what we call a lofted demonstration. It'll test an inflatable heat shield this fall. After launch, it will re-enter Earth's atmosphere, and we'll learn how the design slows down, survives conditions relevant to many potential applications. We can simulate the environment they're going to see on the way to landing towards Mars with an Earth demonstration. And it could be used for that. That's our. But also launch providers could use it for landing heavy payloads on Earth back from space, or recovering rocket parts. So hopefully the missions excite you. I know you're all here, so it must excite you. And I hope to be we hope to be a large part of that. And hopefully the local examples kind of helped a little bit and see what's out there. And I will say the future, I've 39 years at NASA, the future in space has never been more exciting to me than now. So please join us. The path through the moon and sustainable exploration goes through every state. Thank you. Is there time for questions, or did I use it all up?
Are there any questions? And
All right.
if you do have them and you'd rather ask them one-on-one, I believe you're joining us for some of the cocktail hour afterwards.
I hope so. Yeah, I think we
Fantastic.
have a little time. All right,
Okay.
thank you.